Okay, now this is our first bit of code. What we're going to do now is we're going to encrypt an image. It's a very secret image. We don't want anybody to see what our image is. Certainly don't want it to see the whole image, but we don't even want it to be able to guess from what they can pick up by getting our secret messages. We don't want them to be able to tell what the picture is. So that's the idea. We're going to use the Advanced Encryption Standard AES, which we learnt about in the course, and we're going to use that to encrypt it using first what's called the electronic codebook mode. And let's get to it. So, okay, here, where's our picture? We want to see our picture. We want to know what it looks like. So here's our picture. Okay, now that's our picture. It does look like it's very sensitive information, that picture. I can believe that completely. So we don't want our adversaries to know we're interested in penguins, for example. So we want to get this entirely unpenguined. Okay. So we're going to do this, as I say, using the Advanced Encryption Standard, AES. Okay. I'm not going to write my own. I'm going to import one of those. So I'm just importing this. And I've imported that code, and there I go. Now, the thing with AES, as I've said before, is it works on blocks of the same size that are 16 bytes. So if I've got 16 bytes, it's fine. If I've got 32 bytes, it's fine. If I've got 48 bytes, it's fine, etc. But if I had 40 bytes, it wouldn't be able to work. It would get stuck. So I'd have to pad it out to make it the data with extra data to get the data we need, size we need. So we are just taking again, I'm taking from a library, a Python library that will do that padding for me. Okay, so now we're ready to load that image. You've seen the image, so okay. So all this is saying is we're opening up this bitmap. We've got it as a bitmap, and we've got two things we're going to make. We're going to make the header, which is the first 54 bytes of the image, the bitmap, and then the rest of it. Okay, and the reason we separate that off is this header we don't want to scramble. Okay, we want the header to stay as it is. So we separate that off, and we're just going to scramble the data bit. Okay, right, that makes sense. So if you remember how the AES works, well, we're going to have to. It's going to work with a key, which we'll write in a second, and we're going to. In this case, we're going to use ECB mode, and ECB, which stands for Electronic Cookbook. It treats every block separately, as I said before, I think, but it does the same thing with each block, which is to say, if you have two blocks that are the same input, they're going to get the same output. Okay, so that's a feature or a problem, depending how you look at it, of ECB mode. It's how it works. It's entirely repeatable. That's the good thing about that, but it has some problems. Okay, so we're just going to prepare our AES engine, and uh, and so this is just telling us to treat this as bytes rather than characters, and we're going to make it. We have to get the right number, and if you check, you'll see the 16 of them. Okay, so that's the key, and then we just make a cipher with the key and say what mode we're using. And I just said that. So that's what we say. Then once we've done that, we encrypt the pixels. Well, to encrypt the pixels, I first have to pad them, as I say. I take the pixel data, so that's everything but the header, and I say pad that to be in the right block size for what I'm doing. Once I've got that in the right block size, I can just take that and use the cipher I've written here. This cipher is just calling this cipher that AES.new that I made over here. That's this cipher, and saying encrypt these pixels. Okay, that's all I'm doing. And then we just stitch them back together, and the header stays as it was, but the rest of it is now this new encrypted bit. Okay, and so let's see what this looks like. I think I haven't been going around compiling things as I go, so I'll be in trouble, I think. Let's just go back and compile things. Okay, let's compile this one now. Now let's see. Yes, it's good. I have compiled enough. Okay, so, well, what's the problem with this? What's good and what's bad? Well, it's done something, but you can still make out it's a penguin. And why can you make out it's a penguin? It's because of what I was saying about the blocks being treated the same. So I've got all of this was white space, so every block's going to be treated exactly the same. All of this, so if you've got these blocks, if you've got a lot of, and this was, I think, blue space, whatever space it was, it just all gets done at the same time. So I've got to change what I'm doing. Okay, so I've got to randomize this. So this is the key here. So this, I'm loading the image again. I'm now setting it up. This is all the same, but I'm now putting in this random string here. Okay, and when I put in the cipher, I'm putting in the random string here, and I'm using the padded pixels, and then it's all the same except for here. So let's look at this, compare this line with the line here. This is new. This was the cipher we made before. Was just had two inputs, and it was a key which we're still going to have, but AS mode ECB, and this is still this, but it's now got three inputs, and this third input is this random thing, which is going to randomize what it does each time. So, and then we do that, and then we do everything else is the same. I've just put in this extra random bit, and let's compile that. Now that that's compiled, we can look at the picture. That's the picture we get out then. Okay? So, the problem we had here is we needed to randomize the way what happens in each with the same input, because we had this is all this has the same input, but it has different outputs. You can't see a penguin here, so that's the end of this. Okay, see you in the next week.